the addition rule for probabilities. Now you really need to pay attention about what this means. So the addition rule deals with the word or. And what does or actually mean? So using this Venn diagram, let's think about this. So we have events A and B noted by the circles, right? So event A has 1 and 2 and A only, 3 is shared. B has events 3, 4, and 5 where 3 is shared, 4 and 5 by itself. And then we have 6 and 7 that are outside of A and B, but are part of the universal set. So when we're thinking about A or B, now what does this mean? Well, the word or means I will take anything in A or anything in B. What you might have noticed by my shading that I did is that this piece in the middle, where 3 is located, was shaded twice, right? So if we say we have 7 numbers, because we do, 1 through 7, probability of A or B, well, there are 5 numbers there. So this probability is 5/7, right? Because there are 5 numbers out of 7 that are in A or B. Now, mathematically, if I would say, well, probability of A is 3 out of 7, because I have 1, 2, and 3. And then I would say, well, what about the probability of B? Well, that's 3, 4, and 5. That is also 3/7. But I counted our lovely number 3 twice. So let's subtract 1/7 because I only need it 1 time. So if I counted it twice and I get rid of it once, then it's just there the 1 time. So 3 plus 3 minus 1 gives me the 5/7. So what this means is that the probability of A or B is the probability of A plus the probability of B minus the overlap. So the overlap means we counted it twice, and we don't need it twice. So if I count something here and here, but subtract the overlap, you can see that we subtract 1. It is still there 1 time, which is what we want. So let's do some examples. The probability a student takes calculus is 1/8. The probability a student takes chemistry is 1/10. And the probability a student takes calculus and chemistry is 1/40. What is the probability a student takes calculus or chemistry? Okay, so we're going to say the probability of, let's say, calculus or chemistry means we have the probability of calculus plus the probability of chemistry minus the probability of calculus and chemistry. Okay, so what is the probability of calculus? 1/8. The probability of chemistry, 1/10. The probability of and is 1/40. Because remember, we don't need to count them twice. If someone is taking both calculus and chemistry, they are counted in the and, right, both pieces. They're counted in calculus and calculated in chemistry. We only need them in one spot because they are just one person. So now let's think through this. To play with fractions, adding and subtracting, we need a common denominator. So 8, 10, and 40 all go nicely into 40. So let's go ahead and change all our denominators to 40. So to do that, first things first, 8 times 5 is 40. So I multiply the numerator by the same number of 5. 1 times 5 is 5. For my second fraction, 10 times 4 is 40. So 1 times 4. And I already have 40, so there we go. Now we add 5 times 4 minus 1 gives me 8/40, which reduce to 1/5. So the probability a student takes calculus or chemistry is 1/5. Now let's just do some straight math problems, okay? Forget about the application base. Let's go math. Probability of A is 0.4, probability of A and B is 0.04, and the probability of A or B is 0.85. What is the probability of B? I always recommend starting with the formula that we know. So we know the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Because once you have this written out, you can go ahead and just plug in what you know. A or B is 0.85. Probability of A is 0.4. I don't know the probability of B, but A and B is 0.04. Whoop, wrong button. So now when I combine on the right side, right, we're solving an equation. So on the right side, 0.4 minus 0.04 gives me 0.36, and I still have an x, and that equals 0.85. So now to get x by itself, I subtract the value, right, because we're adding x, so these are separate here. So I'm going to subtract 0.36 from both sides, and x gives me 0.49. So the probability of B is 49 hundredths. Let's just do one more here. Probability of A is 0.47, probability of B is 0.31, probability of A or B is 0.68. Let's find the probability of A and B. So again, the probability of A or B equals probability of A plus the probability of B minus the probability of A and B. Let me tell you, the more you write this out, then it just becomes second nature and you're always going to remember. Let's plug in what we know. A or B is 0.68. Probability of A plus the probability of B minus the probability of A and B, which is what we don't know. Again, we're solving an equation. So let's go ahead and we'll combine these on this side. So I get 0.78 minus x equals 0.68. I want to get x by itself, so I'm going to subtract 0.78 from both sides. And I'm left with negative x equals negative 0.1. Well, if I divide both sides by negative 1, that means x would give me a positive 0.1. So the probability of A and B is 1/10. And that is playing with the addition rule for probabilities.